So velocity of A with respect to B, if I ask you to find out, those things you can manage, no? VA
Yes, sir.
minus
I
V.
I can do relative motion and that one dimension I can do, sir.
Okay then. Okay then. So now what we'll do, we'll do a particular kind of questions where it is Rainman problems, okay? So here we are going to use the symbols. VR will stand for velocity of the rain with respect to the ground frame. VM stands for the velocity of man with respect to the ground. So if I write VRM, so if at all the man is not like stationary or anything, he is maybe moving. In that case, the velocity of the rain will not be appearing same to him as it appears to someone who is stationary in ground frame. So that the velocity, the one that is going to be of the rain, the one that you will be seeing by being in the frame of the man, or whatever the man will be seeing, is the velocity of the rain with respect to the man. How to find it out? That will be velocity of the rain minus the velocity of the man. So maybe, so these are not like some new concept, just a kind of profile of questions that you will be seeing. Suppose if I have a case when the man is stationary, not moving, and maybe I have told that rain is falling vertically down. Okay. So the rain is falling vertically down as seen from ground frame, and the man is stationary. So the velocity of the man is 0. So in this case, the velocity of the rain with respect to the man is same as the velocity of the rain with respect to the ground frame, correct? So from ground frame or from the frame of the man, both are identical now because the man is not moving, it is stationary on the ground. So the velocity of the rain will be seen coming down. So tell me how he should be holding the umbrella. Like this, no?
Yes, sir.
Correct. Now, next situation is something where the man is not stationary, maybe running on the ground. And it is told, maybe I'll write that thing in words also, like a question kind of thing. A man runs on a horizontal ground or horizontal road with speed 3 meters per second. And the rain falls vertically with 4 meters per second. And I have to figure out how he should be holding the umbrella to save himself from the rain. So he will be holding the umbrella in a manner such that the rain velocity in whatever direction is, you see the axis of the umbrella should be in the same direction or not. So the axis of the umbrella must be placed along whatever the velocity of the rain the man sees from his frame. So I have to figure out the velocity of the rain with respect to the man. One way to approach this question can be, maybe you think in terms of coordinates. So this is the road on which the man runs. And maybe I consider the man running on this side with speed that is given 3. And the rain falls vertically down Rain falls vertically down with a speed 4. Maybe I'll take some axis for like easy writing purpose. Suppose upward I take it as plus y, and this way suppose I take it as plus x. So using this coordinate axes, we can write what is the velocity of the rain is. So velocity of the rain will be minus 4 j cap or not. And velocity of the man will be how much? That will be 3 I cap. So if I ask you find the velocity of the rain with respect to the man, that is going to be the velocity of the rain minus the velocity of the man. Velocity of the rain is 3 I cap. Sorry, velocity of the rain is minus 4 j cap. And velocity of the man is 3 I cap. So what really the velocity of the rain with respect to the man came out to be? So velocity of the rain with respect to the man is a vector whose x component you see it is minus 3 and whose his y component it is minus 4. So this thing is clear. Next,
Yes.
I will draw this vector graphically, and one easy way can be that taking the same coordinate axes, if I ask you where the coordinate minus 3 comma minus 4 will be lying in, somewhere obviously in the third quadrant, no? Just a moment, I'll make some space for it. This is our x-axis, positive x, and this is our positive y-axis. So if I ask you, where is our coordinate, which is minus 4 comma minus 3, it may be somewhere here, no? Not minus 4 comma. His x component is minus 3 I cap, or his x component is minus 3, y component is minus 4. So where the point minus 3 comma minus 4 will be. So maybe I consider this one is the point whose coordinates are minus 3 comma minus 4. So you draw the arrow whose tail is going to be at the origin and the head will be at this point. So this arrow is going to represent the velocity of the rain with respect to the man which is moving. Now totally you can tell that his x coordinate here is minus 3 and the y coordinate here is minus 4, correct? Then if I ask you, can you find this angle, the one it is making with minus y direction or vertical? I'm calling it as angle alpha. To find that angle alpha, I will use this triangle. This triangle, you see, we'll use different color. This triangle, you see, has got this length equal to 4, no? And this length is equal to 3. So tan of the angle alpha, we can find out totally. That will be 3 by 4, no? Tan alpha equals 3 by 4 means alpha is 37 degrees. So it means the rain will be appearing him to fall in this manner. So maybe now I will draw that vector maybe somewhere else. As you know, we can shift an arrow of a vector parallel to itself. So maybe I can draw that vector here. I can draw that vector here. I can draw that vector anywhere. Just it should be of same length, must be in same direction. So tell me how much angle this one again is, alpha only, no? So this black arrow and this red arrow, both are drawn on the same line. This angle is our alpha. So to the man, the rain will appear coming along this direction. So how he should be holding the umbrella? He should be holding the umbrella like this, correct? So the axis of the umbrella must be lying along the arrow along which the velocity of the rain will be as seen from the frame of the man, no? So in this case, what we are going to do is we will be placing the axis of the umbrella at an angle alpha from the vertical like this. So I hope you got the point now that VRM vector, once you find out, however you find out, the axis of the umbrella lies along this vector, no? So the axis of the umbrella must be placed along the direction of the velocity of the rain as it appears from the frame of the man. Sometime maybe rain is falling vertically and you started moving on your bicycle. You will find the rain, once you start moving, will not be hitting you vertically, will be hitting you at an angle. Same kind of thing is happening here also. So I hope you got the point. Theory is nothing much, just they will be giving you VR, VM, and they will ask you VRM, or maybe they will give you VRM and VR maybe, and they might ask you VM. So some story given, but in every story, the job done will be same. Finding out VRM, writing down VRM as VR minus VM. So whatever I've told, you have understood or not?
Yes,
Any doubt?
sir.
Okay then. Just new questions I can give. Nothing new theory. This much is the only theory. It is just checking you whether you know how to find A minus B or how to find VR minus VM. So I'll take a new page. So try this question. A man runs on a horizontal road with a speed that is equal to 4 meters per second and finds, who finds the man, that the rain is falling vertically determine the speed of the rain with respect to the ground. I hope you understood the question, no? So man runs on a horizontal road with a speed 4 meters per second, finds that rain falling vertically with a speed, forgot to mention that, vertically with speed 3 meters per second. So some story told, but that story is told regarding what? That story is told regarding the velocity of the rain with respect to the man, no? So something is told about a vector, which is the VRM vector, and from that we have to figure out the speed of the rain with respect to the man. So do you want to try, or I should solve it? So when you joined the meeting, man, you were able to understand that earlier slide you were there. You understood, no?
Sir, I'm understanding a little bit.
Just now you have joined.
No, sir, I joined a little while ago.
Okay, so you understood this slide, no?
Yes, sir.
Okay, then to try this question, I will solve it, but you just give it a try. From
Mhm.
whatever knowledge or skill you have, try once. So man runs on a horizontal road with a speed 4, finds that rain is falling vertically. So rain falling vertically is told with respect to whose frame, not ground frame, no, with respect to the frame of the man. So do you want to try or I should solve it? Tell me, accordingly I will then. Maybe try it on this one. I'll give you how much. Just a moment. Time now is 5:56. I'll give you 4 minutes. Suppose if I see a vector which is lying entirely along y direction, then what will be the x component of that vector will be then 0, no? And even the z component, is it not? So velocity of the rain with respect to the man is only along the vertical. One easy way can be, see, whenever you have to find a vector or whenever you don't know a vector, then how many things really you don't know? Suppose you don't know velocity vector of something. So a vector, whenever it comes attached with two information. What is the magnitude or the length the vector has, and what is the direction the vector is having, no? So a vector comes always with two unknown, the length and direction. So in junior maths classes, you must be doing such thing like something is an unknown quantity, you assume it as x. From the stories given in the question, you make some equation containing x and you solve for x. Same thing I'm going to do here. So we don't know the velocity vector, so maybe we will assume him in terms of its components. So let's consider man running this side given to us as 3, not 3, 4 meters per second. And what else is told is this, that velocity of the rain with respect to the man is this much like this. So we have started this question. Now try once, then I will solve it. Just a moment, I'll check if anyone came offline or what. Give me 1 second. Okay, do you got the answer? Or okay, you must have tried something. Now we'll solve. So the thing is, whenever I have to find a vector or an unknown vector, what we do, assume an unknown vector in terms of its components. Because, so if I don't know a vector, I have to assume it. Assuming a vector takes two things. One is we have to assume the magnitude. So maybe we'll say, okay, magnitude x. But the moment I ask you, assume the direction, things will get confusing. Man, how to assume direction, man? Like, so headache. So maybe I can do things like, okay, it is making this many angle from x, this many angle from y and z. It will be like so much hectic. But the moment I know, you understand that the moment you know a vector in terms of its components, I can find his length. I can find everything, like what angle it is making from x, y, z, everything. So that's why it will be like so much easy if you assume an unknown vector in terms of its components. So I'll write that point. So always try to assume an unknown vector in terms of its components. Suppose if I consider that old way only, maybe upward as positive y and this way as positive x. So tell me, velocity of the rain can have some component along x or y only, no? Because the velocity of the rain with respect to the man is along y direction only. Velocity of the man is only in x direction, nothing is along z. So velocity of the rain from ground frame, that vector can have two components only. So I will assume those components, and also maybe I will consider that y component will be negative or positive if I consider upward as positive y. So the y component of the rain mostly or more likely it will be negative now. So we will consider that thing in our assumption only. So we will assume that velocity of the rain has got some x component, let's call it as vx. And his y component beforehand, see, I'm assuming him to be negative. See, it is an assumption, it can be wrong. But so if suppose our assumption wrong, then accordingly we will get the answer. So totally fine to consider him like this. So assuming we are like this, I hope it is understandable to both of you. Like beforehand only, I considered that y component of the velocity of the rain with respect to the ground frame will be negative. Now, what is the velocity of the man is given is, or velocity of the man is 4 I cap. And velocity of the rain with respect to the man is, that is, rain is falling with 3, I wrote 4 by mistake. So velocity of the rain with respect to the man is minus 3 j cap. So we know that VRM will be VR minus VM. Correct? So what is VR? VR is Vx I cap minus Vy j cap. And what is VM? 4 I cap, so minus 4 I cap. So this is our VRMS. So just I will write down here that VRM came out to be equal to Vx minus 4 I cap minus Vy j cap. And what is VRM that is given to us is minus 3 j cap. So I will replace it with that. So minus 3 j cap is equal to Vx minus 4 I cap minus Vy j cap. Now tell me this VRM vector is equal to this vector. What is the component, the x component of this VRM vector is 0, no? Or LHS and RHS are same. Then I cap component must be same as the J. I cap component of LHS should be same as the I cap component of RHS. I cap component same goes for J cap. So what really I have 0 I cap, no? If nothing there means 0 I cap. So what I will write next is Vx minus 4 should be equal to 0. So from that we get Vx is equal to 4. Just I'm making the components equal on the other side. What is the y component he has? Minus 3. And what is the y component he has? Minus Vy. It means minus Vy should be equal to minus 3. It means what is Vy is 3. So once I know that Vx is equal to 4 and Vy is equal to 3, what is the velocity of the rain from ground frame really is Vx I cap minus Vy j cap. So we get 3 I cap, 4 I cap minus 3 j cap. So this is the velocity of the rain. Now to find the speed, we can find out totally that will be 4 square plus minus 3 square, and that is going to be 5. I hope you got the point now.
Yes.
So what really the takeaway from this question is, now you check out what is the velocity of the rain really is. It is 3 I cap. See, I'm writing down 4 I cap minus 3 j cap. And what is the velocity of the man is 4 I cap. So the x component of both of these two vectors are equal, no? Correct? Because to find VRM, what I will do, I will subtract VM from VR. And on finding him out, I find out that it is lying along y direction only. So if it lies along y, what really it tells us that his x component should be 0. If this vector's x component is 0, what really it means, the x component of VR and VM are equal. That's why it kills the x component. So if rain is seen falling vertically, automatically you will understand that velocity of the rain. So maybe I'll write that thing here. If the rain appears falling vertically, it means the velocity of the rain with respect to the ground frame VR, the x component of this guy must be same as the velocity of the man with respect to the ground frame, which is VM's x component, no? So whenever you find rain falling vertically, automatically you will understand x component of VR vector and x component of VM vector are same. So when I take the difference of VR and VM, x component vanishes and only thing that remains is the y component. So in such situation, rain will be seen falling vertically. So tell me nothing, no concept, no just simple thing or not. What concept? VR minus VM. That's all, no? Any doubt in both of you? And any doubt? And you can hear me clearly, no, without any background noise.
Yes, sir.
Okay, then. If you want to have a look, then I will take a new page. Okay, I can take a new page now.
Yes, sir.
Okay, then. I'll give you a question. You try once. Man running with speed 3 meters per second finds that rain falls vertically. When he increases his speed, he finds speed to 6 meters per second. He finds that the rain falls at an angle of 53 degrees from vertical. So determine the speed of the rain with respect to the ground. So two questions we did just now. So it is like two questions clubbed together. So when the man running with speed 3, he finds the rain falling vertically. But when he runs with speed 6, he finds the rain falling at an angle of 53 degrees from vertical. So determine the speed of the rain with respect to the man. So maybe try this question, man. Both of you. So again, you can solve this question in the same manner maybe. You assume that rain is falling with some component along x, some component along y. And maybe beforehand you assume that y component will be negative when I take upward as positive y. Okay. And then how many unknowns you have once I write VR like this, two unknowns. So two unknowns we have, it means we need two equations. So that's why two story given. One story given, one time the rain falls vertically when he is running with 3. Next time when he runs with 6, the rain comes at an angle of 53 degrees from vertical. So you want to try or I should solve it? Try for a minute, then maybe I will solve it. I hope you have tried, no? So two cases are there. Case one, that rain falls vertically, So again, it's like same kind of situation as in the previous problem. So man running this side with speed is 3, and he finds that rain is falling vertically, but with what speed rain falls, that is not given to us. Now, again, what we will do, we will assume that velocity of the rain with respect to the ground frame has got an x component and a y component. And again, sticking to the old way only, upward as positive y, and this side as positive x. So the vertical component of the rain, most probably it will be negative. Generally, rain falls down only, not like it goes away from the ground. So I will assume that velocity of the rain, this is our assumption, that VR vector has got x component Vx and the y component minus Vy. You can assume plus Vy also, then answer will for Vy will come negative. Here I have assumed minus Vy, and if the y component is supposed to be negative, then Vy value you will see will come positive. Now, in this case one, what is told is that velocity of the rain with respect to the man is only along vertical. What really it means, the velocity of the rain has a x component and velocity of the man's x component. Both must be same, no? So I'll find out VRM. So x component of the VRM should be 0. So first find out VRM. VRM will be VR minus VM. VR minus VM will end up becoming Vx minus 3 I cap. I hope I can write it directly. Minus Vy j cap. And this vector's x component is 0. So what is the x component of VRM is Vx minus 3. So the x component of this guy is 3. We find it out, no? Vx is equal to 3. So only thing left is to find Vy. So now if I write down velocity of the rain, it is going to be 3 I cap minus Vy j cap. And velocity of the man in case 2, the velocity of the man is 6. He moves in the same direction, but with speed double the earlier speed. So velocity of the man is now 6 I cap. So now if I ask velocity of the rain with respect to the man will be VR minus VM. And if I do VR minus VM, what we get is 3 I cap minus 6 I cap. And 3 I cap minus 6 I cap will give us minus 3 I cap. No? So VRM vector, you see it is minus 3 I cap minus Py j cap. Now if I ask you draw this vector, so what is the x component this vector has? Negative. What is the y component this vector has? Negative. So whatever this vector is, if I ask you to draw it graphically, can you draw it graphically? Same like the earlier case, no? What is the VRM? We got it as minus 3 I cap minus 4 j cap, no? So x component negative, y component negative, how we have drawn it. Same way I'm going to draw him. So the point which is minus 3 comma minus Vy will be maybe here. So if I take his x projection or projection on the x-axis, here the x coordinate will be minus 3 and y coordinate 0, we know. And if I take his projection on the y-axis, there the x coordinate will be 0 and the y coordinate will be minus Vy. And this is the arrow of VRM vector. And what is told? It is making an angle of how much? 53 degrees. With whom? Vertical. So what is vertical? The y-axis. So this angle must be 53 degrees. Now you check out this triangle. In this triangle, what is the base? Length of the base is Vy. And what is the length of the perpendicular? This is 3, no? So from this triangle, totally you can write what will be tan 53. Tan 53 will be 3 by Vy. And what is tan 53, man? Tan 53 is 4 by 3. So 4 by 3 is equal to 3 by Vy. So what Vy is going to be equal to? 9 by 4. So once I got Vy, means I know the velocity vector, no? So velocity vector Vr has got x component, which we know, and y component also we know. Y component is minus Vy and Vy is 9 by 4. So this is going to be the velocity of the rain with respect to the man, the velocity of the with respect to the ground. And after this, you can find his speed, or maybe I will leave it here. I hope you understood this question also. Any doubt?
No, sir.
Okay, then maybe I will leave it for a moment. Then I will take a new page. Now check out this question, everyone. A man is moving with a velocity 5 meters per second on a horizontal road here, and he finds that the raindrops fall at an angle of 45 degrees with the vertical like this. But when he is running down this inclined plane with velocity 16 meters per second, in this situation, he finds the raindrop falling vertically. So find the velocity of the rain with respect to the man, and you consider this as x and this as y to report the answer in terms of the x and y components. So do you want to try, or I should solve it? So process kind of same. You assume the velocity of the rain to be having some x component, some y component. Two unknowns you have, so two story given. When the man runs with 5 here, the rain appears to be falling like this. When the man runs with 16 like that, the rain appears falling like this. So maybe I will solve this question. A similar kind of thing we have in exercise 3 that you must try today only after the class. Okay. So again, we are going to do that assumption. So we will assume that velocity of the rain has got two components. And to assume that I have taken upward as positive y and this side as positive x. So it's going to be Vx I cap minus Vy j cap. Now, in case 1, the velocity of the rain with respect to the man is like this. The first job will be to figure out the velocity of the rain with respect to the man. This is our case 1. So in this case, the velocity of the rain we have assumed, and velocity of the man is given to us as 5 along plus x direction. No. So velocity of the man is 5 I cap. So velocity of the rain with respect to the man will be Vr minus Vm. So Vr minus Vm will be Vx I cap minus Vy j cap minus of 5 I cap. And that is going to become Vx minus 5 I cap minus of Vy j cap. Clear? So this thing is clear. Now, whatever this vector is, I will draw him graphically. Now this vector, it is told that it is like this. Maybe I'll draw the x-axis. And this downward is our minus y-axis. So our velocity of the rain with respect to the man, we'll draw the complete picture. So velocity of the rain with respect to the man is making an angle of 45 degrees. So I can draw him anywhere. You see, I can draw him here, anywhere. But maybe I will draw him at the place where his tail is at origin and head at the point whose coordinates are going to be the x and y components. So velocity of the rain with respect to the man is Vx minus 5 I cap minus of Vy j cap. Now, before you solve this thing, tell me, if I tell you a vector which are given by this kind of arrows, anywhere I draw the arrow, that should not be confusing you. So tell me, this arrows, whatever they are, their x component will be positive or negative. Can you guess that? The x component will be negative or positive? Positive only, no? So the arrow is like this. Suppose if I tell you the arrow is like this. And this is our eastward direction. And this is our southern direction. So if you travel along this arrow, you will end up traveling along east or west. You will end up traveling along east only or not. So the x component, so if arrows are going to be inclined like this, the way I have drawn this red arrow, its x component will be positive, no? And it is told it is making this 45 degrees with the vertical. So if I drop a perpendicular to the x from the tip of the arrow, that will be giving us the x component. If I drop a perpendicular from the tip of the arrow on the y-axis, that will be giving us the y component. His y component is minus Vy. His x component is Vx minus 5. Now you can totally select any of these two triangles. So if I ask to consider this triangle, this length is same as whatever Vx minus 5 is. And this length is how much? Same as whatever is Vy is. Correct. Suppose this is minus 5. So what is this length will be 5. So it is minus Vy. So what is this length will be Vy. Now from this triangle, you figure out the tan 45. So whenever you have an angle 45 tan, then the x and y components will be of same magnitude. So what we get is tan 45 will be Vx minus 5 by Vy. So from this thing we get tan 45, we know it is 1. So Vy is equal to Vx minus 5. That is going to be the one equation. So from case 1, we got one equation. From case 2, we will get another equation. I hope case 1 all of you have understood. Because for drawing case 2, I will need the next page. Case 1 understood, no?
Yes, sir.
Okay. Case 2, he is running down the inclined plane, no problem. Same approach we are going to have again. So it's running down an inclined plane. So this angle is theta, which is given to us as 30 degrees. So totally you can tell this angle will be also theta, which is going to be 30 degrees, correct? And the man is running down this inclined plane with a velocity which is Vm, and that is given to us. So basically, I have to find the velocity of the man in terms of the components along x and y. So what kind of directions we have selected? Upward as positive y, this side as positive x. So this Vm will have a component in this direction, and will have a component in this direction. So you can totally see this angle is theta again. So component of Vm this side will be Vm cos theta. Component of him in y direction will be along minus y. That will be Vm sin theta. So velocity of the man with respect to the ground frame in terms of x and y components will be Vm cos theta I cap minus Vm sin theta j cap. Vm is 16. Let's check once. 16. Theta is 30. So 16 cos 30 I cap minus 16 sin 30 j cap. And that is going to give us 8 root 3 I cap minus 8 j cap. So this is the velocity of the man. And velocity of the rain is Vx I cap minus Vy j cap. Next job will be to find Vrm. And that Vrm will be Vr minus Vm. Vr minus Vm will be Vx minus 8 root 3 I cap minus of 8 minus, just a moment, minus of Vy. Together I write down as 8 plus Vy j cap. And what is told regarding this Vrm vector is that it is vertically down or it is vertical. It means this vector's x component should be 0. X component of this vector 0 means Vx minus 8 root 3 should be equal to 0. It means Vx will be equal to 8 root 3. And that is going to be our equation number 2. Once I know Vx, now once I know equation number 1, what it was, Vy equals Vx minus 5. So Vx we know, Vy we know. So Vx we got it as 8 root 3. Vy will be 8 root 3 minus 5. So velocity of the rain, I have to answer it in terms of the components. And what is that? Be careful, don't do that silly mistake. Y component is minus Vy. So Vr will be 8 root 3 I cap minus of 8 root 3 minus 5 j cap, and that is the answer that they are asking us. I hope it is clear now. So every time what we were doing, man, every time Vr minus Vm, Vr minus Vm, some story given, using the story, we find whatever is the unknown things. I hope this is clear to everyone. Abhinya, Karthik, you were there from the starting, understood, no? Those who were absent, I'll save the recorded session. And first recorded session also, it is very compulsory to watch, and you cannot understand this if you don't know how to find the relative velocity vector. And that is done in the backup one. Okay, this thing clear, no?
Yes, sir.
Then write down the homework that you will be trying today only. Exercise 1, question number 1. Question number 14. Exercise 2. No questions of Rainman in exercise 2. Let me check it once more. Exercise 3 we have. Exercise 3, question number 4 and question number 7. Four A, no question. 4B, no question. Then beginner boxes are there some. Beginner boxes, man, just a moment. Beginner boxes are same as old module. This is like old module. Beginner box 2. Question number 1. Question number 9. So not like so many questions are there of Rainman. So this much only. So I'll share the recorded session. The attendance was very less, man. Live class is live class. So backup one I have taken already in the weekday batch. Check out the recording. Next class, if you find that okay, you need live class, I can give live class again. But maybe if you can manage with the recording, we can use that time for doing something else also, no? So I'll share this recorded session. So today I did very less things. Because Karthik, you came without. Abhinya, you have seen that recorded session, no? Rishi and Nishant, I think so. You've seen recorded session, no? If not seen, please see it today. Okay, this one also. Because we don't have much time also, no? I can take class again, it's not a problem. But if maybe we can save time, what is wrong with that? Okay, then bye everyone. See you. Tomorrow maybe I'll keep class. Today night I'll post when I can keep class. So tell me what timing you will be comfortable to join. What timing? That timing only I will keep. What timing? Tell me, Nishant and everyone.
The same as this. Same as today.
Same as this. Maybe I think tomorrow my week off. No, so tomorrow I can take in other time also. Maybe 7 p.m. like that also fine. No.
Ah, yes, sir.
Okay.
Yes.
Then so after 5:30, anytime I will see. Okay.
Okay, sir.
Okay. Then. Okay. Then bye bye. See you tomorrow. Don't miss the class tomorrow. Okay.
Okay, sir.
Okay, then. And watch the recorded session also. Please see Nishant, Karthik. Please watch the recorded session. First one compulsory. Then only you can understand the tomorrow's class. Or if you not watch, I will be taking the same thing. Waste of time, no? Watch it at double the speed. Okay. Okay, then bye bye. Thank you for coming in this class.
Sir,
Thank you,
what
sir.
time is tomorrow's class?
Tomorrow I will post what timing. Maybe after 5:30 only I will keep. Okay. So that everyone will be back from school or something. Okay. Okay then. Bye everyone.
Bye, sir.
Thank you,
Thank you,
sir.
sir.
Okay.